Smart Textiles, Smarter World. Spark innovation with the SmartX community.
So when we are at the middle of the conference, yesterday it was really interesting sessions, really related into industry, and these companies are actually outside on another room presenting their developments. Moreover, we had as well a few minutes of listens of posters that we have a poster exposition that we're going to visit right now. So we are here at the posters exhibition with one of our SmartX members. So welcome.
Hello.
What do you have to explain us about the evaluation of textiles electrodes for bioelectronics signal and acquisition using a stimulated muscle scheme model? Too long the title, that's the only thing I can say for the moment.
Thank you, Judith. I will just break it down in very quickly. So we have already showcased this project work in one of the E-textile conference last year, but this is an extension which we bring in a form of poster with some of the new results that we have achieved. And here in this, we want to bring and show that there is a characterization setup, a standardized characterization setup, which is also a focus of E-textile conferences and E-textile committee to standardize the processes. So we want to standardize the testing of the or characterization of dry electrodes, which is very much used in a lot of variables for sensing and medical applications. We kind of add the function of signal simulated biosignal, which can be read through these over this setup and see how one electrode from one construction of textile technology to another textile technology construction, how they vary and what is better. So it helps us in getting and characterize your developments. Yes.
Okay, that's interesting.
Yeah.
So I hope next year you are going to have a presentation on the project, and maybe soon in any of our webinars. So.
For sure. We are trying to wrap more and bring up more results, and we will try to bring it more to the platform also.
I see it's because I see pictures only, so I think it's integrated.
Yeah.
With,
So the aim also is like to use these textile technologies for textile electrodes, and in different technologies there are different methods of making textile electrodes. So in knitting and weaving and embroidery, they have different methodologies. So we testing all the methodologies, also different structures that you can achieve from it, and different material that you can test from it, and this all can be is done in this study.
Okay, so thank you. Looking forward to hear more about it. So welcome, another poster from the ITF, a new member of the SmartX Innovation Hub. So what do you have to say about it?
It's a new development from the company Traugott Baumann and the ITF together. And the idea of this project was to develop a new contacting aid in form of a hybrid yarn. So you already use conductive threads to get interconnections. The problem is in textile you have a lot of alternating stresses or strains, and that leads to a deterioration of your interconnection, because conductive yarn relax and so on. And that's why we wanted to improve that to get more durable interconnections. And we developed a yarn that combine adhesive filaments with highly conductive filaments.
Okay.
So that was the first development, to develop a processable yarn, and then we use this yarn as a normal sewing yarn to connect two conductive elements. It could be a conductive textile, a wire, yeah, and you have to activate this interconnection thermally through hot pressing, for example, and at the end you have molten the adhesive part. You've got a contact between the conductive yarn and the conductive textile, for example, so that you have a mechanical adhesion due to the stitches, but you have also this chemical adhesion due to the adhesive part.
Okay,
Yeah.
interesting. Yeah.
And of course, you have to determine the different parameters to connect, to melt the yarn. So you have to determine which pressure you want to apply, which time, which temperature. That's what we did in this study. And at the end, we wanted to validate these parameters by embroidering. These heating textiles.
Yeah.
So you can see here the interconnection is quite big because it's the beginning of the project, but we use different kinds of hybrid yarns. The difference between the yarns is based on the type and the amount of adhesive filaments.
Okay.
Yeah, and as you can see here, we compare the results with a normal conductive yarn. And with this yarn, we can see here in white hotspots at the interconnections, and you don't have any hotspots with these hybrid yarns.
Okay, so it's for the moment it's working, so it's better for interconnectivity. And have you tried to weave it or not yet? Only embroider?
It's we don't want to weave it because these yarns are twisted. They are special. They are developed for sewing and embroidering.
Okay.
Developments.
Interesting. And which applications do you see for this yarn, like towards the future?
It's for e-textile. When you use textile, for example, you don't want to notice an interconnection, a hard interconnection, and this is the main aim we want to achieve with this interconnection, because you can bend the textile without noticing any hard part, and yeah.
Okay. And are you going to try washability as well as one of the parameters?
Not yet.
Not yet. Okay.
Not yet, but the durability, we didn't make any durability test, but it is planned, and we have to. Yes, the study is ongoing, and that's why we have to test it.
So I hope to have you soon presenting some results of this study in one of the SmartX webinars. And maybe next year in the Textile Conference.
Yeah, it would be a pleasure.
Yes.
Thank you.
Okay, thank you, Valerie. Thank you. So we're still at the posters, and I found here Miguel Rocha.
Miguel Rocha, exactly.
Rocha from Senti. I'm trying to pronounce correctly the Portuguese names, but slowly. And what are you going to tell me about your poster?
Yeah, this is a project that is ongoing right now. And we are developing single and double-size blankets in which we are integrating conductive yarns and sensors, all textile-based solutions. So every solution, the heating elements and the sensors are always, all of them are yarns. As for the heating systems, each one has the capability of adjust their temperature at 3 different heating levels. And as for the sensors, we are integrating temperature sensors to monitor in real time the temperature of each heating system.
Okay.
In the case of the presence sensors, we use it to automatic shut down the heating system based on the user's presence, and we also integrate, in this case, liquid detection sensor to improve the safety of the solution, because sometimes we can drop some water and could be dangerous to the user. As well, in this project in particular, we had some difficulties in the process. Mainly in the integrity of the textile during the finishing processes, namely the washing and carding. Yeah, because we are integrating different types of materials, textile-based fibers, metallic-based fibers. The properties are very different. During the washing, the textile ones try to retract more than the metallic ones, and then the metallic ones then form some loops and being damaged during the carding. That is the process to make the blankets fluffy. So in this case, we want to do a solution like you can see in the image. So in this case, fluffy. But to overcome this problem, we need to do some ID on top of the textile structure to improve the durability and the resistance of the conductive yarns, and to avoid them to being out of the structure and being damaged during the carding. Right now we already achieved some good results in terms of stability of the heating elements of each heating system. As for the temperature sensors, as you can see in these graphs, we also have very stable solutions. As for the other types of sensorization, namely the presence and the water detection, we already validate the solutions in lab outside of the blankets. Right now we have already endorsed blankets with these solutions, but we didn't analyze yet the performance. However, for the presence ones, we had some issues on the integration, and most of them were damaged because this sensor it's a mixture between the textile-based fibers and metallic ones, and something happened during the process. So in this case, we need to improve the solution. But mainly we have that. We also are developing a mobile application, of course, to interact with the blanket, but we also have this part, to make a physical contact with the blanket and to do some basic interactions like turning it on the blanket, or even to select which heating system we want to start heating up.
It needs to be all the time plug it, or it can...
If we want to make use of the solution, yes.
Okay.
But if we want to use as a normal blanket, no, don't have a battery. No.
If it had a battery for, I don't know, 1 hour or 2 hours,
we didn't integrate in this solution battery for that purpose.
Okay. Yeah. And do you think then there is potential to scale up these blankets?
The main object is to scale up this solution. And because of that, all the solutions that we are integrating are conductive yarns, and we are studying the interconnections between the base bars and the yarns that connects to electronics with these sensors and heating elements. So, but it is a very difficult task.
Yes, I know. Yeah.
But
and I know that you're quite well positioned because of the consortium that I see. It's Sentient Endeavor helping probably on the development.
Yeah, exactly.
Testis Penero, that they are already in the blankets market.
Yeah, exactly.
So that's really important. And as well, but it's really important, it's to have like the integration of the app. So thank you, Miguel.
Thank you very much.
Hi, I'm Erik Karnowski from Graphlen company in Sweden. We do graphene coating of textiles. Different textiles for the fashion, technical textiles for composites, for example. Our method is unique because we do coating of the thinnest atomic layers called graphene flakes, and we do this coating on the level of the fiber, inside of the deepest inside the fabric. So the fabric is still the fabric. So it's not a paint, it's not the resin, it's a... We used to say that we are changing the DNA of the fibers. And we can control how much graphene we put, we can control the electrical resistance, we can tune it to different applications. Anti-static, signal transmission, heated applications, for example. Electromagnetic shielding is one of the most exciting functions also. So we add different functions to the fabrics. The important aspect is that we use only water and graphene, no binders, no metal, nothing, and it's very sustainable. And even more, we add only literally few grams of graphene per square meter, 2, 3, maybe 4 grams, which is usually 1, maximum 2% of the fabric weight. So it's extremely lightweight. We are now doing that on the industrial basis, so we can produce hundreds meters per day, and we believe in the innovation on the fiber. Thank you.
Hi, my name is Svea Timpont. I'm a researcher at Hogeschool Gent FTI Lab, the University College in Ghent. And today I will pitch you the poster, the SmartX connector. The connector is a patent-pending connector, and it's a self-aligning, detachable electrical connector for e-textiles. It's a lot, I know. So I will present to you this. I will come a bit closer so you can really see. There you go. So this is our first prototype, also here on the poster, and this is a cross-section of our connector. You can see in blue the magnets, and these ensure that the conductive layers in yellow and in red are being attracted towards each other, so the conductive layers are immediately on top of each other. This design minimizes the additional materials, and also the magnets are being put in the electrical module and in the textile module without any adhesives like glue, etc. This is being done with a push and click system, and here it is just in between the layers and fixated with a stitch. So it's easy to repair and recycle at the end of life. Because of the eco-design regulations are very important, we take also this into account. The features and characteristics of this SmartX connector we can say in 5 points. First of all, it's a detachable system, so components and overall. That enhances that optimizes the washability and the maintenance, because the electronical part you can take off and the textile part you can just wash. It's self-aligning, so depending on the place where it is situated, it's easy, just the usability, it enhances the usability. So there's a minimum number of conductive components and materials. It's for the reliability, to ensuring the reliability, minimizing the points of failure, and also it's quite cost effective to minimize those materials. Also, all the components that you see here are off the shelf available. So the last point is the adjustability. Depending on your function or your application, you can change the size of this overall connector. You can change the magnets, you can change the embroidery in something else. It's all depending on your application. So with this, I will end. If you have any questions, you can contact me. So please get in touch with me. Thank you very much.
Hello, so my name is Radek Soukup, and we are with our colleagues. We are coming from the University of West Bohemia, from Research Center Risse, and we come here with several developments which we did with our industrial partners. One of them is so-called hybrid threads. It's a thread which containing continuous textile filaments and microwires. So the beauty of that we can have the resistance, linear resistance, down to 0.2 ohms per meter, and we can have the different types of metal microwires. So it's possible, for instance, to make a thermocouple out of that. These microwires were introduced to the market with our industrial partner, WB company, under the brand CleverTech, so it's possible to buy it. And you can embroider it, you can integrate it into the woven structure, so you can have something like that. It could be even stretchable. And we also developed several products with other industrial partners, such as Smart Firefighter Suit, which was also introduced to the market, or several kinds of smart firefighter glass, which can measure the temperature of the remote objects by integrated infrared thermometer, or there is also thermocouple for measurement of ambient temperature. Currently, we are working with another industrial partner from Italy on the inertial localization system, which will be integrated into the boot, firefighter boot. So it's possible to localize a firefighter indoor where there's no GPS signal. And here you can see there is the glove, which is, we call it LED compass, which helps a firefighter to navigate. So you can navigate firefighter indoor, or there is also the function, we call it way back function. So if a firefighter is lost somewhere, he can press the button and automatically he or she is navigated out of the building. So
how does it work? Via Bluetooth or?
No. It's the connection between the boot and the glove is through Bluetooth, but the navigation is based on inertial sensors. So magnetometer, accelerometer, gyroscope, and algorithm, which was developed by Italian company Dune. Yeah.
Okay. And how is the integration made? I mean, what do you use? Embroidery, printed electronics?
Well, mostly we use weaving, we use embroidery, we use knitting, and we develop several technologies for integration, direct integration of electronic components into the planar structures.
Okay.
So one of them is also was based on ultrasonic welding. We developed it together with Fraunhofer IZM. The other one is based on the encapsulation, on printing, 3D printing thermoplastic enclosures. We put the module or electronic component and then put it to the heat press, and you have really good encapsulation, and you get a very good encapsulation contact in one manufacturing step. So that's.
Okay.
So that's.
And have you, I don't know if you're at the States, but have you tried the standards for the firefighters? So, I mean, the jacket, or
Yeah.
do they pass the standards?
Yeah. It's mandatory, because if you want to introduce to the market, you have to go through the standard. But during today's discussion, we learned that still the standards are missing. So what we have to do, because this both the glove and also the firefighter suit is standardized according to the explosive atmosphere standard, ATEX and ISX. So we have to standardize at first electronics according to the standards, and then the textile.
Okay.
So it's standardized, but not according to electronic textile standard.
So I'm Tom Gregg. I work at the University of Southampton. This poster was a bit of a side project from my normal professional work. It grew out of binding my PhD thesis, which I finished last year. One of the kind of techniques that you use in kind of traditional book binding in order to put titles and decorations on a book is gold tooling, which is the process of applying like very thin gold leaf onto the cover of a book, adhering it down in a specific pattern, and that's how text and patterns are traditionally made. But gold's a conductive element, and I have a E-textile lab to work in. So this was kind of a bit of an experiment to see, could you use that process to make E-textile circuits on the cover of books? So, the process is that you make an indentation in the pattern in your circuit design, you apply the gold leaf over that, adhere it down using the same tool to get the kind of specific shapes you want, and then you just rub off the excess. And that's, in theory, you can use that to make anything that like a single layer PCB would have. Attaching components is slightly more complicated because soldering doesn't really work on things that are kind of that finer scale. But one of the E-textile techniques we've used is using conductive epoxy in place of solder, and that kind of works here as well. You need to use a kind of adhesive underfill on it in order to get the kind of mechanical strength you need. But if you do all that, then you can get something like this, which has a microcontroller, LEDs, and if you power it up, they can flash in whatever pattern. And you can extend that in theory to any sort of thing you could do with a electronic circuit. And so it was all just kind of a nice, fun side project. It's not terribly practical, but it's kind of interesting to see where these E-textile techniques can be applied to weird and wonderful things.
Hi, my name's Reese. I'm a product design engineer from the Centre for Process Innovation in the UK. I'm at the E-textiles Conference presenting work on a project called Heatleaf. This project was for an SME that has only one person deep. That one person is the director, Joanna Newton. She came to us with an idea for a heated stump sock because she herself is an amputee and suffers firsthand the complications of having an amputation. We took her through the early stage product development process. We looked at various heating solutions for textiles, including conductive threads, conductive fabrics. Joanna eventually left us with a working proof of concept demonstrator alongside a product test bed in the form of a medical phantom with embedded temperature sensors to prove the function of the device without needing to be worn by a user.
My name is Jiří Navrátil. I'm from University of West Bohemia, and we are designing special equipment for fencers. With a high school student, we designed a conductive ribbon. This is the standard cable the fencers are using. It's quite rigid, it's quite heavy. And we designed one from E-textiles, from E-textile ribbon, from conductive textile stretchable ribbon, which is 50% lighter, which is much more flexible, and which can help in the sport and in the wrist motion. Because the sport is very dynamic, very energetic, and you need to have a lot of flexibility in your wrist, and much more flexible cable connection make the sport and the attacking much better. There is a button actually, so you have to recognize it with the button.
And
so
the
funny.
textile it's inside? No, the textile is the connection actually. So
The textile is the connection. This is the textile
I see now the
stretchable.
difference, that it is stretchable.
Because they are connected with this,
Yes.
and this is quite rigid and quite heavy. So this one is stretchable,
Okay.
textile based, and you have like, because if when you are fencing, you are like this, and you need to have a lot of wrist motion.
Okay.
And if you don't have a wrist motion,
You
doesn't
don't.
really work.
Okay.
So maybe at first when you put the cable, when you put the textile cable, you feel like, oh, I'm not connected because I don't have a wire. But at the second that's the case. You don't want to feel the wire. So at first it's weird because you don't feel it, but that's the right because you don't feel it.
You don't feel it, yes. Are you already scaling up? So it's already like being used.
We would like to. We would like to because we are. This one is stretchable, as I say, and the Veronica told that she don't really need the stretchability.
Okay.
So we are now switching to the different ribbon, which would be not stretchable, which would be fully insulated, and which would be directly welded inside the connector. This one is soldered, so it's like a first prototype. Now we are developing some small PCB inside of the connector.
Yes, I see it.
There is the PCB for the connection, and we can directly weld the new ribbon like this.
Okay. And it's still it's stretchable.
Yeah. This one is still stretchable, but we will have not stretchable version. And when we have non-stretchable, fully insulated, I think it will be maybe ready for the market. So then we can test it. Maybe we know some fencer from Czech Republic who has the biggest e-shop with the fencing equipment in Czech Republic. He's Olympic winner of bronze medal actually last year. I think his Beran is his surname.
Okay. Yes.
And maybe we will talk to him and discuss it with him if he want to test it and if he want to some more scalability for the system because
That's interesting, yeah. I would like to see it, yes.
It's like I would say it's only a cable. So there's not much to do to be ready for a market. Because it's like only a cable, but you need to have a proved connection inside, and you have to prove that the durability of the ribbon. We have already
the comfortability. I guess you have to test it.
And we also tested the durability of the ribbon, not for the cable, but for the ribbon, and it can withstand like 750,000 bending cycles in like diameter of 2 millimeters,
Okay, so that's
which is quite good. So we tried to test the cable, but the data was somehow corrupted from the test. But we can feel that the cable was really blackish here when we were bending it. Like after 2,000 cycles, it was really black.
Okay.
So maybe if it withstands the same as the cable, it will add you much more comfort and much more confidence in fencing.
Because you would not feel that you are
even if it withstands like 50% and give you much more flexibility. If you are really beginner fencer, I think it doesn't really make matter. But if you are pro fencer, even small step up of your opponent can give you the chance to win, the much better chance to win.
Okay, yeah.
So the more professional, you are more looking for the details.
Okay, great.
So overall, I hope you liked that video, and I hope you find interesting the posters exhibition that we had some brief definitions of all the posters there. So thank you, and hope to see you next year.